So today I gave you two numbers to start a pattern, and you were asked to work with your math groups and tell me if you could extend this pattern in 4 different ways. So let's share some of our discoveries.
So we did the most one, which was add 5 for each, 5, 10, 15, and 20.
Okay, and then what else did you do there?
And then we did add 5, then add 10, and add 15, which gave 5, 10, 20, and 35.
Okay.
And then we did plus 5, plus 15, plus 25. And we could also have another bubble on top of it, which could say like adding 10 for the pattern rule.
Okay.
And for the bottom, we found out that we knew that 5 times 2 is 10, which could also be another pattern multiplying by 2 each time.
Okay, so before we continue and see other groups, is it obvious to see the pattern that this group has created? Because I like how you said we obviously knew 5 and 10, skip counting by 5s, which is one of the earliest things we learned when we had to deal with numbers way back in, the early grades, like grade 1 or grade 2. You learn how to skip count by 5s, and you were excited about it. Still kind of gets us excited because it's an easy thing to do.
We got a couple different methods, but the most one was, I guess, these two, like these 4. Because of this one we did, decrease, like adding and decreasing. So we did 5 plus 5 is 10, then 10 plus 4 is 14, and 14 plus 3 is 17. And for this one we did 5 times 2 is 10, and then 10 times 3 is 30, and 30 times 4 is 120. And then
so one of the complex ways that we did was times 3 minus 5. So 5 times 3 is 15, but minus 5 is 10. So then so then we did it with the rest, and we got 25. So it is over here because 10 times 3 is 30. And then 25 times 3 is 75, and then we just minus it by 5 each time.
So this group created something here. This is where we're heading in algebra. So this is almost like a formula or a generalization. This is where we're going to get to. So don't panic if you don't know what they're doing. Okay? So things are starting to get obvious, but I think one of the obvious things you guys have realized is that even though we started out with 2 numbers, the pattern could look very different. And you just proved it. Some groups had 6. I was walking around, some of you had 6 on your paper, 5, 4, and then you're telling me there's still many more ways. Okay? Now I'm going to adjust the question ever so slightly. I'm going to add another term to this. And I want you to tell me if you can extend this in 4 different ways. The new term that I am adding is that. So now that you've had time to work on this, I've given you the first 3 terms and asked you, can you extend this pattern? And one of the questions that was asked is there only one answer? So let's figure out if there is only one answer. Who would like to start off?
So, it depends on what kind of pattern you want to do. If you could do only times 2 plus 5, if you could do add more than 2 values to add it by, then there's more than one way. But if you could only do it by one number, there's only one way to do it, which is 5 plus 5 plus 5.
Okay.
So that's what we did. But if we were allowed to do more than one number, instead of 5 only, so it would be more than one. So 5 times 2 equals 10, plus 5 equals 15, times 2 plus 5. So
Okay. Are there any other contributions that you guys would like to make?
So, well, we did the same thing. We did 5 plus, it was plus 5 for each one. But then, like Ali said, if you wanted to do more than one operation to get to the next number, you can break 5 down. You can do plus 2 plus 3 would be 5, 10, 15. And then if you went to 20, you can do that too.
So this here and this here.
It's kind of the same.
It is exactly the same.
Because if you did 2 plus 3 plus 2 or 2 plus 2, you get a 5, and that's basically plus 5.
So these two are pretty much the same. So let's count them as the same.
Yeah.
we got 5 plus 5 is 10, plus 5 is 15, plus 10, and plus 10. This one.
Okay, so I see that you're doing plus 5, plus 5, plus 10. Okay, so that's different. Anything else that's different? So basically the answer is we can have multiple patterns, even if we start with the first 3 terms. Any other differences?
Okay, so basically we never wrote it down over here, but it was supposed to be like this. 5 plus 10, and 5 and 10, it will be plus 5, and it will be plus 5 again. And then we did 5 plus 5 is 10, and then plus 10 over here. And then from there to there, we did plus 10 again. And then it will continue like this, and then we will do plus 20 from here, because these two add to 20,
Okay.
and we go on like that.
Okay, so you'll see over here, we got add 10 and subtract 5.
Okay.
And over here, this is a bit complicated. It's times 2, and then times 2 minus 5, and then times 3, and then times 3 minus 5.
Okay, so there are some sort of established pattern. The one that I was totally expecting you to do, which maybe sometimes when a task, I make it so easy, you guys look for the more difficult thing to do. But one of the most obvious ones was, what if I put the number 5 here? What's the pattern? What kind of pattern have I just created now? Hiram?
Is it like kind of like the
So basically, what's the next number?
yeah.
10. And then 15. So this right here, okay, so this right here, so instead of extending patterns, we can call it describing patterns. So maybe that's where the confusion came in. You guys thought maybe extending it means it had to grow or shrink or whatever. But it also could mean just repeating this. Do you guys know what it's called when a certain number, a certain part of the pattern gets repeated? Remember, it has a special terminology. The core, yeah. This is the core. Okay? So it gets repeated. That's the only answer I didn't see, but that is another type of pattern. So basically, we've discovered that even if you started off with 3 numbers, the pattern can